Okay, so what if I told you about a machine that learns what an image is all about? Not because you tell it, but just by trying to copy it. It sounds almost too simple, right? Well, that's the powerful idea behind a really key concept in AI that we're going to break down today, the autoencoder.
At its heart, an autoencoder's primary goal is surprisingly straightforward. It just learns to perfectly reconstruct whatever you give it. You can almost think of it like a high-tech artist, a forger. But here's the catch. It has to do this after squeezing all the information through a tiny, tiny bottleneck. So here's the basic blueprint. We feed it an input, say this image of the number 2. It then flows through these two symmetrical halves. First, an encoder, which creates a really compressed code, and then a decoder, which has to try and rebuild the original 2 using only that code. The whole system is trained on just one thing: make the output look exactly like the input. So let's zoom in on that first part of the journey. What is actually going on inside the encoder?
Okay, so the encoder's job is to be incredibly efficient. It takes that detailed input, every single pixel of that number 2, and it's forced to compress it, funneling it down into a much smaller, much denser representation. It has to figure out what's truly essential because it literally can't keep all the information.
Think of it like this. It's creating a super condensed summary. The encoder takes all of that raw, messy data, and it learns a function to just distill it down to its most important features. The result? A compressed, kind of elegant representation of the original.
All right, so now we have our compressed summary. But that's only half the battle, right? Now we need to see if that summary is actually any good. And that is the job of the second half, the decoder. The decoder's task is pretty much the mirror opposite of the encoder's. It gets that tiny, compressed code, our summary, and its only job is to try and rebuild the original, high-fidelity input from just that. It's basically expanding that summary to test how much information was successfully saved.
So in short, the decoder is the decompressor. It applies its own function to expand that dense summary back into the full, detailed picture, trying its best to reconstruct the original input perfectly.
So we have the compressor and the decompressor. Now let's step back and look at the whole elegant process working together as one system. This really shows you the complete data journey. Original input gets encoded into a compressed representation, and then it gets decoded back. This process of squeezing a huge amount of data into a smaller space is a really powerful technique called dimensionality reduction. The autoencoder is forced to learn the most meaningful dimensions of the data just to have a chance at succeeding. And this just highlights that perfect opposing tension in the system. The encoder compresses, the decoder reconstructs. It's this symmetric challenge that forces the network to get really, really good at one particular thing. And that one thing is learning to perfectly copy the input to the output. The entire network from end to end is optimized for this single, simple goal. Which brings us to the most important question of all. If the goal is just to copy something, why would we go through all this trouble? Well, the magic isn't actually in the copying. It's in what the network is forced to learn about the data structure in that compressed middle layer. That hidden representation, that's where the real value is. And it's the key to everything from cleaning up noisy images to discovering powerful hidden features in your data.